Hi, everyone. Hello. My name is Wojtek. I'm a developer advocate on the Android team at Google. And today I'm going to talk a bit about modern app distribution on Google Play. Now, if you watched one of the talks yesterday, you've probably heard this already, so I'll be really quick. We have this notion in Android of something called modern Android development. And it's a set of our recommendations or recommended technologies that we think every Android developer should be using in their apps. And modern Android development has four pillars. A modern language, that's Kotlin, a modern IDE, that's of course Android Studio. Then there are modern libraries, mostly Jetpack. And finally, there's modern distribution. And at the center of modern distribution on Android is the Android App Bundle format, which replaces publishing APK files to the Play console. But in order for developers to get there, to be able to do that, first, another crucial Play feature needs to be enabled. And so I'm going to spend quite a lot of time today talking about Play app signing and explaining why it exists. And also, I'm going to try and guide you through some of the choices you need to make when enabling it. Then I'll explain some App Bundle basics before I move on to more advanced topics like Play feature and asset delivery, and some of the additional APIs and tools that we have in the Play core library. So let's get started. So Play app signing, what is it? Let's start with a definition maybe. In short, it's the ability to securely store the app signing key on Play's infrastructure so that Play can sign APKs on your behalf. Small side note, this was formerly called app signing by Google Play in the console and throughout our docs and other materials. Recently, we did some renaming to simplify and streamline App Bundle related products. So we use the term Play app signing now, which kind of works together well with Play feature delivery and Play asset delivery that I'll be talking about later. So why was Play app signing created? The main motivation for creating this functionality was that key management is hard. Only some of the largest developers are able to come up with the necessary processes and infrastructure with comparable security to what Google can offer. And for the average developer, this is simply too difficult. And I don't mean average as a pejorative term or anything, by the way. It's just a question of resources and scale. And this is not some scare tactic, by the way. There have been instances in the past where developers of successful apps on the Play Store lost their keys. And due to how app signing on Android works, and the previous model where the developer is solely responsible for keeping their keys secure, in that model, it was technically impossible for Google to help in this situation. There was no way to recover their key, and thus the developer would have no way of sending updates to their app. With Play app signing, we mitigate that risk, and I'll talk about more on that later. Now, the other thing that Play app signing gives us is that now that signing is possible on Play's servers, on Play's infrastructure, Play can generate and optimize APKs based on changing conditions such as device properties, the user's language, operating system version, and so on. And we'll cover details of that in later parts of this talk. Now, I wanted to take you through the process of opting in to Play app signing. Even if you've done it in the past, I think it's good to listen again for two reasons. I'll try to list the pros and cons of each of the choices available to you. And it's important because once you select one of them for your app, you can't go back and change your mind. And the second reason is that we recently launched a completely new, dare I say, modern UI for the Play console. And some of the stuff may have moved around, so maybe you're not so familiar with the UI yet. So first, let's take a look at enabling app signing for a fresh app that is one without any published versions. You actually make the app signing selection on the first time you create a release. So it's not on the app signing page in the Play console, it's on the page where you create your first release. And it's literally the first thing on the screen, but it's kind of easy to miss because it's enabled by default with the recommended settings, and all you need is to press continue. The recommended setting is for generating the key on Google servers. But there's also a Manage Preferences button, and what you choose here is very important. So let me break down the choices available. So here are roughly all the choices that we have there. First one is the default, where you opt in, but you don't provide an existing key. This is the most secure option because if you never own the key, you can't leak it. No one can intercept it. You can't lose it. That's why it's the recommended way to go. However, there's one big caveat that you have to remember about. Play app signing does not offer a way to download the generated key ever. That's why if you need to be able to use that key for signing locally, you can use the option to upload your own key. Now, the downside of that second solution of uploading your own locally generated key is that even though Play can now use that key to optimize and sign your app when distributing bundles, you are still responsible for managing that local copy of your key, making sure it doesn't leak. And by the way, you still cannot download the key in this situation. So it's the same as in the first choice. You uploaded the key, you cannot download it again. So if you want to have continued access to it, make sure you don't lose your copy either. And the third option is only used for very specialized scenarios where you need to share data between apps. And that is by reusing a key from another one of your apps that are already opted into Play App Signing. The Android platform offers several ways to share the sandbox, the secure sandbox on the device for apps signed with the same key. But it's best to only use this if you fully understand the implications, as misuse can lead to privacy or security issues between the apps. So only choose this option if you really need it, if you know what you're doing. And now, for all of these options, the choice you make here is irreversible, meaning that once you opt in, there's no going back. Of course, there's still a fourth option, which is to opt out of Play App Signing and continue uploading self-signed APKs. In that case, you can decide to opt in to app signing at a later time. And a final piece of advice that is applicable to every scenario here is to always use a separate upload key, which can be reset in the case of if you lose it or if you leak it to a third party. Now, let me show you how this looks in the UI, so maybe that'll make it a little bit clearer. Here's the typical case when you upload your own key from a Java key store. First, you download something we call the PEPK tool, which you will use for encrypting the key for transfer, just so it's really secure when you send the key to Google's servers. You can also get the source code for the tool to inspect it or to use it in your own custom infrastructure, maybe for exporting the keys, if you're not using a plain Java key store. And then at the bottom, there's an optional part that I highly recommend for everyone to actually do, which is to create a separate upload key. So if you open that option, you are given a chance to upload your locally generated certificate with a public key, which will be used to verify that any artifact that you upload to Play comes from you. This signature will not be used for distributing apps, and it is stripped from any uploaded artifacts in the Play console, and then replaced with the app signing key that Play holds. The upload key's purpose is so that you don't continue using your app signing key day to day, which would reduce its security. If you use the upload key, I recommend you delete the app signing key if you don't need it anymore. While remembering what I said before about not being able to recover or download the app signing key from Play in the future. Now, if your upload key gets lost or stolen, first of all, the attacker won't be able to distribute fake updates of your app because the upload key is not used for the final signature. And secondly, you can always reset the update key by contacting support. So that's a good thing about that. Okay, so that was all a situation for new apps where there were no previous releases and you had the choice of either generating the key on the Play infrastructure or uploading your own. For existing apps, it's a little bit different because you don't have the choice of generating the key on Play's infrastructure. Since there are already versions of your app published, you have to continue using the existing key. The recommended way to go here is to upload your signing key using the PEPK tool. Use a separate upload key, and then delete the signing key if you don't need it. That's the most secure option, because that way you don't have to keep maintaining the security of your local copy of the key. Alternatively, as before, you can keep the key if you need it, knowing the risks. For existing apps, you can also continue to self-sign APKs, and that won't change for the foreseeable future. We haven't announced any changes here, but you won't be able to use the app bundle format and any of the advanced delivery options that I'll talk about later. So if you want to use these, you should opt in to Play App Signing. And here's how the UI looks like for an existing app. Now, to opt into app signing, you actually go into the app signing page as opposed to the releases page as previously. And even though you have 3 options, they all do the same thing. They let you upload the key. They just use slightly different ways to achieve it. The first one takes a file that you can generate in Android Studio's UI in the Generate Signed Bundle option. The second one, you use the PEPK tool with a Java key store manually. And the third one lets you use the PEPK source code in your custom integrations. But ultimately, every time you encrypt the key and upload it to Play. Okay, so after Play App Signing is enabled for your app, here's how the Play App Signing page looks like. First of all, it will show the certificate hashes that are sometimes required for registering your app with various APIs. Many of the Google APIs use this, for example. If you have a separate upload certificate for uploading your app, if you want to test locally with that, you will also see the hashes for that upload certificate here. And so it's handy to register both with the APIs. And there's one more feature here that I want to briefly mention. Sometimes if you maybe created your key a long time ago and it uses security that is considered weak today, or if your key leaks to a third party and you want to start moving to a new one to ensure the safety of your users' data, you can request a signing key upgrade for new installs. So that's the option here right below the certificate hashes. Now, why isn't this just called key rotation? That's because this feature doesn't actually use the key rotation introduced in recent Android releases. What this does is it will deliver APKs signed with a new key, but only to new app installations, such as when users change phones or uninstall your app and then install it again, while existing users will continue to get updates signed with the previous key. That's why the transition to the new key isn't instantaneous with that option, but it helps move users to the new key eventually. We are exploring the possibility of adding true key rotation for Android 11 and newer devices, but nothing to announce just yet. We're still exploring the technical possibilities here. And now, before we move on, I just want to get one question out of the way, which I often see developers get wrong, and I'm sure it will come up with it in the Q&A anyway. So if I opt into Play App Signing, will I be able to still publish my app in other channels, other stores? And the answer is, of course, yes. Play App Signing doesn't take any choice away from you or the ability to publish your app elsewhere. And there are actually multiple ways of doing this. Either you upload your own key to place servers and keep your own key, keep a copy of that key locally, knowing that you will have to continue managing its security, and you can continue using that key locally to sign any artifacts that you upload to other stores. Or the second option, you use the key stored on Play's infrastructure and use the App Bundle Explorer functionality in the Play Console UI to download signed versions of your app for distribution to other channels. And I will show that in a second. Or, no one says that you have to use the same signing key for different distribution channels. So you can just generate different signing keys for other stores. There's nothing, but be aware that in that case, users will not be able to update the app using a different distribution channel than the one used to originally install it. Now, for that second option of downloading artifacts from Play, what you can do is you can open the App Bundle Explorer, choose the version you want to download on the top right. It's the latest one by default. And then switch to the Download tab in the middle and scroll all the way down. And here you can see there's a couple of download links, and one of them is a signed universal APK. So that's the one that contains all of the app's resources, everything that's needed that you can take and distribute elsewhere. And speaking of App Bundle Explorer, let's move on and talk about the Android App Bundle format. So again, first some definitions. As I mentioned before, the Android App Bundle is the new publishing format for Android. But what does it mean? Why do I keep saying publishing format? An app bundle is not installable on Android devices. It exists only to upload or publish your app to the Play console, and later it will be turned into a set of APKs that are optimized for a specific user's device through the use of Bundle Tool. Now, Bundle Tool is open source on GitHub, and it provides the de facto specification of the app bundle format. I'm not aware of any other spec that you can read, but it's all there in the Bundle Tool. It's updated regularly, maintained on GitHub, so you can take a look at the internals or just use it locally. Now, previously, when we talked at conferences and in our documentation, when we talked about bundles and generating optimized APKs, we also used the term dynamic delivery. But due to the recent naming changes that I mentioned, we decided to not use it anymore. It was just confusing, and it wasn't clearly defined what dynamic delivery really means, so we just got rid of it. Now we just say that Play generates optimized APKs from the app bundle. And then there are new names for some of the technologies that I'll mention later, like Play Feature Delivery. Now, switching to publishing using an app bundle is usually zero effort for most apps. Instead of building an APK, you build a bundle from your Android Studio project, and that's it. Of course, to be able to upload it to Play, you have to opt into app signing first. And when I say most apps and with zero code changes, there are several exceptions. One of them being if you have a dynamic language switcher in your app where you might need to change something. But for most apps, it should work as it is. Now, the benefits of using app bundles, I think, at this point should be quite clear. Instead of shipping the same universal APK to everyone, to every user, with tons of potentially unused assets and resources, Play Store optimizes that for you and delivers only resources for the user's device screen density, CPU, and selected language. Splitting via screen density and ABI was possible using multi-APK before, but it was so hard to manage that few apps actually did it. Now with AABs, so Android App Bundles, you have a single artifact, a single upload, and more importantly, a single version code per upload. Unlike with multi-APK, where each one had to have a different version according to some arcane rules that no one really understood. But that's not all. The best thing really with app bundles is that you get even more optimizations in the future as Play develops and adds them without any work from you. One example that we added in the past years was serving uncompressed native libraries for achieving smaller updates and smaller on-device size, only for devices that support this. So depending on device API level. And that was really difficult to achieve before, even with multi-APKs. And lastly, of course, with bundles, only with bundles, you can use Play Feature Delivery and Play Asset Delivery, which I'll cover in a second. Now, going back to that one example of an app that maybe needs to change something in their code or build in order to move to app bundles, Normally, there aren't any things that you need to change, but there is one configuration block in the build files that might be useful for some situations. For example, again, if your app has a dynamic language switcher inside the application, so it doesn't rely on the operating system language, but rather lets the user switch the language of the app. And that usually assumes that all languages are installed together with the app, that all are available at any time. So in that case, you might want to disable splitting by language, because otherwise, if the user switches the language in your app, the app will crash because the other language split would not have been installed. For that use case, however, it's also possible to use one of the PlayCore APIs to dynamically request language installation at runtime. So you don't have to actually turn this option off here, but this in turn requires some coding. So different possibilities exist, but this is really a corner case, and not everyone will have to deal with this. Now, because of those benefits, as well as the fact that for most apps, it's not really difficult at all to switch to bundles, we'd like everyone, every app, every game to switch to app bundles soon. The latest data shows that apps published with bundles get, on average, 50% size savings, which is pretty substantial. And that's why we recently announced that app bundles will become a requirement for new applications on Google Play sometime next year. We haven't decided on a date yet. We will, of course, communicate that early so that everyone has the time to be prepared. But until then, we're gathering feedback about any missing parts of the developer experience with bundles. One of the questions I get, usually get, is will this also affect existing apps on the Play Store? As I said before, no. Right now, there are no immediate plans to make this a requirement for existing apps. But if you create new applications after the date where we make the requirement, then they will have to use Android app bundles and, by extension, also Play app signing, because it's a prerequisite. Okay, now I just want to go over Play feature delivery very quickly. It's not something we're going to go very deep into. And I'll also mention the differences between this one and Play asset delivery, so you know which one to choose when. I won't go into details of the API that lets you install modules on demand, as this will be used by relatively few apps that have a legitimate need for it. But it's a topic for a whole other presentation. So Play feature delivery, what is it? It's a feature of Google Play that takes advantage of some features of the app bundle format. So in the app bundle, you can have optional feature modules besides the main base module of your app. And then you can configure the way Google Play delivers them. They can be delivered either on demand using the API that I mentioned, or at install time, so together with your app when the user installs it from the Play Store, or conditionally based on configuration that you specify, such as the user's country or the user's device's hardware capabilities, like does it have a camera or not. And finally, some modules can also be delivered as an instant experience. Now, feature modules are really like any other module in your Android project. So they can contain text code, resources, and assets. And they are intended for apps that have a use case that needs one of the custom delivery types that I mentioned. So for example, maybe your app has a certain functionality that is pretty substantial in size. Maybe it weighs 20 megabytes, but is only used by 1% of your users. Maybe there's it doesn't need to be delivered at install time together with your whole app if no one is going to use that 20 meg functionality. So you can move it to on demand and create this experience where it'll be delivered as requested by the user at runtime. Another use case is if you want to have an app, for example, that is larger than 150 megs in size total, then you can, of course, move some of that functionality to feature modules that will be delivered later. Now, there's one thing I want to mention that probably not everyone is aware of yet about install time modules. Now, I've seen some developers modularizing their app to achieve maybe better build speeds or maybe just better code architecture in general by using install time modules, because they thought, in any way, all of those install time modules get installed together with my app. So there's no way this could go wrong. There's no coding required and so on. But in fact, we found that too many install time modules in previous versions of Bundle Tool created a slight performance hit when installing the app. Well, it's actually not slight, a substantial performance hit when installing the app. So many modules meant that many install sessions had to happen, and it just took a lot longer to install your app. And so we made a change in Bundle Tool 1.0. That's the one that will be included in Android Gradle plugin 4.2. If you're using the Canary version, it's already there. And it makes one important change for install time modules. They are now non-removable by default. So previously, you could go and use the PlayCore API to uninstall this module to save some space on the device. Now, if you want to do that, you would have to add a new removable attribute to that module. So that's an important change if you've been using this functionality. So be aware. Okay, and so how is this play feature delivery different than play asset delivery? Play asset delivery is also a feature of Google Play that takes advantage of some optional modules that can be present in app bundles, but this one is more about asset-only modules. There's a slight difference on the delivery modes for these. So they can also be on demand, so you can also request them at runtime whenever they're needed. They can also be install time, so delivered together with your app as it's installed from the Play Store. But now the third one is different. There's a mode called Fast Follow, which will basically start downloading right after your app is installed. So maybe you can show the first game screen, and then additional resources, additional assets will keep downloading in the background. Now, asset modules, as the name suggests, can only contain assets. And what I mean by that is you have an asset folder, and whatever you put there is up to you. There's no structure that you have to follow. It's completely opaque for the operating system. What you put in there, it will be delivered and unpacked in your in a folder, and you can use it, whatever files you put there. Now, there is one thing that is new that actually requires that you use a certain directory structure, and that is texture format targeting. And you can read it about it in our documentation. It's already live. And from what I've said so far, like assets, textures, you can probably guess that this is more intended mainly for games. So this replaces the old legacy OBB files, also called APK expansion files, and it's used to deliver really large assets like textures, levels, game packs for games. So yeah, that's the main difference. Play feature delivery for any app, also delivering DEX, bytecode, Android resources, whereas Play asset delivery is mostly just for assets for games. And as I mentioned before, both these technologies use something called the PlayCore library, which contains APIs that you will use to dynamically install and uninstall feature modules and asset packs that are delivered through both of these. Now, the PlayCore library, as I said, currently contains 4 APIs. So Play feature delivery lets you install and uninstall on-demand modules and language splits. Play asset delivery for on-demand installation of asset packs. And then it has 2 APIs that are not related to app bundles, in-app updates and in-app reviews. These can be used by APKs as well, but they are kind of still connected to the Play Store experience, right? So that's why they're in this library together. And then there's a KTX version of the whole PlayCore library, which uses coroutines for all of these APIs that I mentioned. All of them are asynchronous, and so Kotlin and coroutines works really well in that case. So if you didn't know about this, if you're trying to integrate one of these in your app, please check out the KTX artifact, KTX version. And Playcore also has one interesting feature, making development and testing, especially with on-demand modules and asset packs, a lot faster and easier. It supports something called the local testing mode when used in conjunction with bundle tool. As of now, this is unfortunately only supported on the command line. And again, that's maybe why many people don't know about this. But the idea is you build an APK set from a bundle, passing in the local testing mode, and this is super important. Then you push the app on the device using also bundle tool, using the install APKs command. Now, when you run the app, Playcore will automatically detect the local testing mode and use a different implementation for Play feature delivery and Play asset delivery that installs modules from local storage rather than Play. And this is super useful, especially in early phases of development when you don't want to keep uploading to Play just yet. Now, we also have a sample that shows some of these. Currently, it uses Play feature delivery, in-app updates, and in-app reviews. It contains an on-demand module, but it also adds a Gradle task for that local testing mode. So it makes it a little bit easier if you want to try it out. You don't have to use bundle tool directly. It has a custom Gradle task that helps you with that. It's all in the README. And it showcases kind of the UI experience with in-app updates and in-app reviews, so you can try them out yourselves. And the last thing I want to mention, we'll just have maybe 2 or 3 minutes for questions after this, is internal app sharing that lets you actually test all of these with a real Play Store implementation as if it was published on a real track to real users. So internal app sharing is the quickest way to share your app during development, mostly with your development team. First of all, before you use it, you need to have a version published on any of the tracks first. But then you can use internal app sharing to quickly share even the debuggable versions of your app. There is no version code restriction. It's available within seconds. And you can, as I said before, with it, you can test things like in-app reviews and in-app updates, which are difficult to test locally without an actual connection to Play. And to use it on the device, on the tester's device, they need to enable developer mode in Play Store first. So in Play Store settings, tap the version number a few times and then turn on internal app sharing. And lastly, in App Bundle Explorer, you can also get an internal app sharing link for any past versions published on any of the tracks. So for example, you could use internal app sharing to install an older version of your app to test in-app updates when you have new versions published. So I think that's it. That was a quick walkthrough of the things that I think are interesting about all the app signing and bundle related functionality that I hope, that I think not many people knew existed. And I hope that you will find it useful if you try to migrate. So now I think we just have a quick moment for some questions. And I'll also be part of the panel later today. So if we don't get to any questions now, I can try to answer them later. Okay, so first question, does this mean you upload APKs bundles without signing on Android Studio when you sign up for app signing? No, so you still need to upload signed artifacts, either APKs or bundles, but they will be signed with an upload key rather than the app signing key. This is just for additional protection so that no one can upload artifacts to your Play console without actually having your upload key. And that's also why I mentioned having a separate upload key is important to not keep using your app signing key, as it's just safer. When will a different language be downloaded if I switch the OS language to a previously not selected? On starting the app or while setting the language? Will the other strings XML be kept? If I remember correctly, the other resources will be kept. They will not be uninstalled, I think. And basically, when you switch the OS language, it's up to the Play Store app to wake up and download the language. It should do it before your app starts. But I don't think there's a kind of a well-defined moment when this will happen. Although maybe I can double check on that and before the panel, and then maybe I'll get back to this because I don't have a 100% answer. Is it possible to influence bundling options from inside of third-party library which have internal localization and language switch logic? Oh, good question. I don't think so. You probably need to just inform the user that they need to disable splitting by language in the README of your library. So yeah, I don't think this is possible. Can we still ensure that the user downloaded APK will have a set of languages defined by us and not by the user device defined languages? Our app can change language on the fly independently of the device. So the way to do it is disable splitting by language, as I showed in one of the slides. Unfortunately, you can't select which languages will be sent to the user device. It's just all of them that you have in your project will be fused with your base APK, and all of them will be available. Do all of these also apply for private distribution? I guess you mean the type of distribution on Play Store for your company, for your domain. I'm not familiar with this. This is more used in enterprises. So unfortunately, I'm not able to answer this question. I'm not familiar with private distribution. Can I have different app bundles to distribute different features and the users to choose which app bundle to install? Or does this apply only for device configurations? No, the users can't choose which app bundle to install. They will get the app bundle that is active on the track in the Play console that they are in. However, you can modularize your app using, for example, conditional modules, where you can, for example, deliver different modules based on the user's country. Firebase app distribution does not support app bundles. Should we migrate to internal app sharing? Can we expect integration? So I've heard this before. Unfortunately, I don't know if Firebase plans to add support for app bundles. I think they should at some point, but I haven't talked to that team, so I cannot confirm if this is the case. I think internal app sharing is great, and it's really useful when developing, when sharing the app with yourself on the device or with testers. But I know Firebase app distribution also solves some other problems that developers need solved. So maybe I'll try to reach out to the Firebase app distribution team and ask if they're planning this kind of support. That's a good idea. Will APK still exist in a year if we don't want to distribute it through Google Play? Definitely. I mean, as I've explained, the app bundle format is a publishing format. It's only used on the Play Store infrastructure, but then APKs get installed on the device anyway. And APKs have been the format for many, many years. So even if we wanted to change this, we still need to think about supporting all the previous Android versions. So I don't think it's going to change anytime soon. Even if we come up with something new, APKs will continue existing for a while. Is it possible to make these types of optimizations without posting to the Play Store? Yes, but it would make it difficult to. So if you want to post APKs, for example, on your website, it would be a little bit more difficult for users to install them, because usually these optimizations require multiple APKs to be installed as one app. So previously, a user could download a single APK and install it. Now, if you wanted to use Bundle Tool, which you can, Bundle Tool is open source and it has all the optimizations that we are making. But it generates an APK set, which is a zip file with multiple APKs. And so you would need to give the user instructions on how to install that. So while it's feasible, it's easier if there is a an application store like Play Store that does that for you. But the technology is open source, so anyone can adopt it. Does app sharing need a specific Android version? As far as I know, no. It's more about the Play Store version, which is auto-updated on devices anyway. So anyone with a relatively new Play Store version, and it's been out for about a year, I think, should have internal app sharing. Where is it possible to find documentation about all this? Yes, it's on developer.android.com. We have a whole section on app bundles, as well as Play feature delivery, Play asset delivery, and the rest of the Play core library. We actually made some changes that streamlined the documentation a little bit, but we're still hoping to make it better by end of this year to combine some topics, make it easier for developers to be able to read like from start to the finished implementation. So more changes coming. And then also on our Medium, medium.com/Android developers, we posted quite a lot of articles about in-app updates, internal app sharing, and there's more coming. So thank you for all the questions, really good ones, very interesting, and I'll be available at the panel today. So see you all. Thanks.